Now that we've reviewed explaining the slope and intercept in context of a scenario, we're going to look at another skill we know, and that's taking a value for x, substituting it into our equation, and then using arithmetic to simplify and find our y value. We're going to look at this from two different perspectives. The first one is called interpolation, and that's interpolation with an I, like ice cream. And this is where we take reasonable values of x and we substitute them into the equation. So what does this idea of a reasonable value of x mean? Okay, there's kind of two different ways of looking at this. The first one is to use the data points themselves as a guideline by looking at what our smallest and largest x values are. So for example, on this ice cream one, it's looking like maybe from about here to here are kind of the x values where our data points are hanging out at. And so if we're choosing values of x to plug into our equation, we're going to choose values that are in and amongst where our points are already at. Okay, so that would be between the min and the max is kind of another way of thinking about that in terms of our x values. There are also practical considerations. So suppose our variable on our x-axis is the number of days in the year. Then our min would be 0, and our max would be 365, maybe 366 in a leap year. And so there's that practical limitation there that kind of sets our boundaries for what would be reasonable values of x. You could also run into issues like negative values that don't make sense in context of the situation, or extreme values. So if we're looking at this ice cream sales one, a temperature of 1500 degrees Celsius is really not very realistic. And so if we're using those types of values that are outside of this range where we find our interpolation, we're going to call that extrapolation. Okay, that's extrapolation with an E, like elephant. And you're using points that are outside of the reasonable ones. So you can kind of think of this as like extraterrestrial. It's outside of the planet Earth. These are outside of where our data points are hanging out at. All right, so with that in mind, we've actually already written a sentence that involved plugging in a value of x. And that was our interpretation of the intercept for the ice cream sales. So I want to take another look at that sentence. So we wrote, when the temperature is 0 degrees Celsius, our ice cream sales are negative $159.50. Okay, that negative doesn't make a lot of sense because typically sales are just the money you're bringing in. It's not necessarily looking at that overhead. So this sentence doesn't seem to make a lot of sense as it's written. And that's where you're going to start to see issues of extrapolation. So the reason that that sentence doesn't make sense is that we're dealing with extrapolation there. Okay. So let's take a look at what x value it was that was plugged in. So our sentence is when the temperature is 0 degrees. So our temperature is our x variable. And so that 0 is the number that was plugged in. So the value of x that was used in the intercept sentence, that's x equals 0. And so we know that that is going to give us extrapolation. But we wonder what other values of x are reasonable and what values are going to be unreasonable. So we're going to look, our x variable is our temperature. So we're going to use this process of looking at our data points. So it looks like my smallest one is somewhere around 11 to 12. So any number like that, 10, 11, 12, I'm going to use 11. I'll just go a little bit outside of my min. Okay, so that's kind of the lowest side. And then as I come across, it looks like my highest number is maybe about 25 or 26. So maybe I'll use 26 as my upper end. So if I choose a value of x between 11 and 26, and I plug that into the equation to get the y value, we would call that interpolation. So those values are going to lead to interpolation. We use anything outside of that, so smaller than 11, or bigger than 26, then we're going to run into extrapolation. All right, so let's practice the interpolation part. If the equation of the line of best fit is y equals 30x minus 159.5, what are the predicted sales when the temperature is 21 degrees? Okay, so we're going to take y is equal to 30 And we'll multiply that by the 21. So we're going to replace our x with our 21 degrees. And we'll subtract off 159.50. So let me grab a calculator for that. All right, so let's go ahead and put this in a calculator. We have 30 times 21 minus the 159.50. So we get 470.5. So if the temperature is expected to be about 21 degrees Celsius, we can expect that we're going to sell about $470.50 worth of ice cream. So this is actually a really important skill. One of my first jobs out of college was running a 160-acre city park that had a snack shack. And we didn't have a lot of space in our freezer. So it was always a juggling act of how much ice cream to order versus how much frozen food and which ice creams. And so what I did was I collected a lot of data like there is here. And I used that to make a formula that would tell me how much I would need to order based on what that predicted temperature forecast was. So this is something that could really help a business or in a lot of different scenarios. So come back in the next video, we'll look at some other ways to use our regression lines with interpolation.